Well, why don't we start anyway?
I think the surest way to get someone to arrive is to start the
Start,
show.
yeah. Yeah, let's do that. Well, thanks for everyone joining, and thank you, Nate, for suggesting the topic. And I got to remember to tell everyone that they're being recorded. And we might most likely will be posting the video. So by attending, you're consenting. I don't know, Nate, do you have, you want to share anything? You want to start with
Yeah, sure.
your solution?
I don't mind. Yeah, I guess I can share my screen. So I always, these kind of puzzles, I always end up doing them wrong. It's funny because it's like the same thing happens whenever I do um, like uh, um, like interview questions. Like whenever you do an interview question, it's always like, oh, there's a problem. It's naturally to use a double linked list or a red black tree or a blah blah blah, and it's like um, I always end up doing things more of a brute force kind of a way than and anyway. I was pleasantly surprised when I was done that I went and I looked, and it was a lot very similar to the way that Eric Norman's solution was. So I was like, oh, okay, there was no secret like behind the back of the envelope kind of a thing that you had to just know. It was like, no, just anyway. But so I basically I first tried to figure out if there was a way to go through everyone and try to figure out like keep like a state along the way. But eventually I just figured out that what you can do is you can find out where the vowels are essentially, and then go and figure out for every letter what's the distances to all the vowels, and then you just take the lowest absolute value of all those, and there's your distance. Um, so the nearest vowels here, this is basically the top level function. I think that's what you're supposed to call it. But I find all the indices, and I just go from 0 to the last number, because at that point in time, it doesn't matter what the characters are. You just care about the distance. And shortest distance is, well, I guess vowel indices. This is one of my like, I don't use it enough, but it's always fun to use it when I use it. Map indexed. Because it's like, oh, I have a map I want to go through, or a array I want to go through, but I want to know like what my index is along the way. So it's just you just map index instead. Now you get two arguments to your map function. So I just grab when the vowels are when it's in the vowels, I get something there. So I filter some, and so like if I run the vowel indices here, you can see over here, it's 0 and 4. So it's the 0th position and the 5th, the 1st and the 5th, right? I often do this with my code. I don't know how many other people do this, but I often like put these little functions at the bottom after my function, especially when it's pure like this, and try a bunch of different inputs. Usually I don't actually leave them in the code. I delete them usually, but I let them in just as an example. And then shortest distances, you basically take all the indices and then what index I'm currently looking at. So you find the distances, you take the absolute values and do the minimum of it. So that's a pretty straightforward. Anyway, This one's a fun one. Nearest vowels for the whole alphabet.
Hmm.
It's over here. So I don't know. Was that a good explanation? Does anybody have any
Yeah.
questions?
Well, I probably did something pretty similar, but slightly different. One thing that I see that you've done that I did not do was to handle the uppercase characters. The
Oh,
upper
yeah.
vowels. Actually, let me see if I can, if you want, I can show you my solution as well.
Yeah, sure.
But let's see if I can. Don't know enough about Zoom to do it properly, but let's try it.
Hey, Desmond. He's joining audio, I think.
Hey, Desmond. I don't think we can hear you. It looks like you're talking, but I can't hear you.
I can't seem to be able to share my screen somehow. Let me try one more time. Can people see the screen?
Yeah, I can see it.
I can see your screen. Still can't hear you, Desmond, FYI.
Okay. Anyway, so here's the one that I did, which was like it's similar to yours. It's a little bit probably more compactized, but it's doing the same thing. The one other difference was that I used heap index rather than map indexed, which
Very
is
cool.
over yours, but otherwise it's pretty much the same. I wonder if did most. I haven't looked at the Eric Norman gist. Is that like mostly similar solutions, or
Yeah.
did people come up with
It
different
was
ones?
it was definitely similar to what you and I have done. Yeah. Although I think he has a lowercase in there. I think a lot of the solutions threw a lowercase in there to take out the upper possibilities.
My solution is pretty similar as well. So
Sorry, I couldn't hear who.
Julia, did you say something about your solution?
for me,
No, I don't know who was speaking, but I couldn't hear someone who was speaking.
okay, no, I was just saying that like I think our solutions are pretty similar. Like that was what Eric had. He had a keep index and then he had a map index afterward.
I think isn't keep index essentially sum map indexed?
Yeah,
Filter sum.
that's
So it's an even more compact
filter.
version of what I had.
Yeah.
That's cool.
So, but that was one of the core functions that would be useful as well, like you were saying about map indexed as well.
Cool. Yeah.
Yeah, Julia, do you have anything you'd like to present, or?
Yeah, sure. Yeah, here. Let me share my screen right now. You guys can see my screen, right?
Mm-hmm.
Yes.
Okay, so pretty much here's my function nearest vowel. So I have a vowel, so it's just a set of what is it, lowercase vowels right here. And then I have the LC function. It just pretty much converts the string to lowercase. And then for vowel indices, I use the keep index. So basically, if the letters of vowel basically return the index. So keep the indices to where. So basically, in the letter string, keep the indices in which the keep the indices in which the characters of vowels. And then what I did was I did a map index. So return zero if it's a vowel. And then if it's not a vowel, then just go through the indices. Just do a subtraction of the index, of the absolute value of the index, and then return the smallest one essentially. And that's pretty much all there is to my function. And then here I ran I ran each of the test cases that he had plus the one from the link that he provided. It takes you to like a JavaScript page, like it's like apparently it's like an expert level solution or like expert level problem, whatever. But it was one of the test cases there, and then here's just all of them essentially. So that's all there is to the solution, really.
Yeah, it looks like I like your map indexed there. That in contrast to mine, it don't need to do that other the range one.
Yeah. So yeah, that's it for me.
What editor is this?
This is a VS Code.
That's cool. I don't think I've seen anyone use VS Code yet. I mean, I'm sure people do. I'm sorry.
Yeah, I mean, I just know there's it's called Calva, I think. It's like the like what's I don't know how to say it. It's like basically what's used for like Clojure. Just a bunch of stuff for Clojure, but yeah, I know the community usually revolves around Emacs, Cursive, or Fireplace for Vim, but yeah.
But I think
That's
Calva is
cool.
getting a lot of play recently.
Yeah.
Mostly probably because of VS Code.
I see.
Does it like connect to nREPL so you can like evaluate code in your editor?
It does, but like I haven't tried it out yet. Like I'm still kind of new to Calva.
Gotcha.
Here, let me... Okay.
Cool. Well, my solution is a lot like what we've seen so far. I will. Is it cool if I share?
Yeah.
I just lost everyone.
Oh, I see you.
Yeah, still connected here.
Having trouble here as well. I think it's the Zoom.
Oh. Can you hear me, Doran?
Yes.
Okay. Okay. Is my screen sharing?
Yes. Yes.
Yeah. Okay. Cool. This is just wordy with a lot of comments. So when I first looked at this, I got it wrong. I got the whole problem wrong, and I just did the nearest vowel in the alphabet. So I was like finding, like, what's the nearest vowel just in general in the alphabet? That was wrong. Okay. Vowels. This is actually where I solved the problem correctly. I'm going to move you all down here so I'm not. Hold on. Zoom reshuffling here. Okay, better. So I basically did the same things as you all here. Actually kind of morphed this over time as I was like looking for ways to do it. So keep indexed. I think I had, I don't know, we'll get to that in a sec. What I ended up doing, this wasn't the first approach that I took, was that I mapped with vector, and then I like actually fed an increment into it, the string, and then I ran the function, is it a vowel, over that string. So I ended up with a tuple of vowels. I got to that, I'll get to here in a sec, because I was really trying to think about ways to once I got it working, I was like, well, how can I make this faster? And it doesn't really matter over a little string, but I actually used test check and I generated like a huge, like a million card, and I fed into this thing, and it was awful. Like it was bad. It was really bad. Actually, I don't have a consistent test for it because like what I should have done was generate a string with known like vowel sets, right? Like with a known number of vowels, because I'm getting really inconsistent timing. And I think it has to do with like how many vowels are here, because for every character, we're basically iterating through, you know, mapping over the whole vowel set.
Right.
So vowel set grows, you know, we're going to go through there, you know, each time.
Yeah, these are n squared, right? For time complexity. Like in the worst case, it's all vowels, and so you're looping over the whole list for each letter.
Yeah, I believe so.
Mm-hmm.
My fuzzy math says yeah, but so one of the things that I did as the first step to reduce this was really like I was like, well, I had a map inside of a map. I was stacking some maps up. So I was like, well, if I use a transducer, I can do it in one pass, do these transformations in one pass instead of, because really I needed to get like the first item from my tuple to get the index number, right? Like after checking if it's a vowel or not.
Mm-hmm.
So mapping through to find those vowel positions, there was just one place there where I could compact a couple passes over it into one pass with the transducer. Performance wasn't my first concern here. I was like, I just got to get this working. But then I was just like, well, that's an interesting problem because it gets real bad. And then like you all, I just mapped over all to get all the distances and then applied the min to like each vowel in the set. I did some tests by, well, can I make it faster with pmap? And that did seem to help. So on my multi-core machine, just that change of pmap helped. But it was bad enough. I was like, is there any way to make it like a lot better? And honestly, I couldn't really find a way to do that. I tried looking at iterations of 4, you know, because there are constraints you can put into 4, and is there any way? But I couldn't find any other way to do that. But what I did do is this solution, you know, pretty good. So get the vowels. For the vowel index here, I used keep indexed. So I found that function, like I didn't really know that was there. I think we saw code in each of your solutions is a lot like this. And then I map over, this is like your code, Nate, mapping over the distance to nearest vowel. But in this solution, I got a little more complicated in that distance to nearest. Instead of just mapping and taking the min, which required to go over the whole sequence, I basically do some checks. Like, so what I wanted to do is like, I want to go get to the place where we're distant, we're somewhere close to a vowel, but not and then we can bail out once I've like, if I'm between 2 vowels, then
Right. You just go to each one, the nearest by.
Yeah. So if it's empty, well, let's see here. So passing the indexes and the value, this is the same signature that you had, Nate. And then I get the low and the high from that. I know they're in order. Is the difference between min and max? I think this is faster by doing first and last over the ordered list. So if it's empty, I return an empty list. If the value is less than the low, then I'll take the low minus the value. If it's higher, then I'll take the value minus the high. Otherwise, then I do this like sum, and I check if it's between 2 vowels, and I'll take the absolute of that, roughly. Oh, well, I don't have to absolute it. I have known math here, and then I take the minimum distance to the lower or the high. And that sum gets, oh, this is probably full of bugs right here, but to get the pairs, what I first did was I used partition, right? And so partitioning by 2, but that if I'm partitioning by like 5s, if my values are like 5, 10, 15, 20, and I partition by 2, then I'm going to check from 5 to 10, and then I'll check from 15 to 20. So I found I was missing.
Oh yeah,
missing.
Gotta have that.
Yeah, between those 2 partitions. So what I did here, which may be problematic at the end of, like when we get to the end, I actually didn't fully test it, is that I took map again and I vectored indexes and rest of indexes. So that gives me tuples of the staggered. So I get 5, 10, 10, 15, 15, 20 by using the first, well, by staggering the vowel indexes. Did that make sense? I hope that makes sense.
Yeah, definitely. Reminds me that the partition function takes another arg, which you can say like how far to go. So you can say 2, 1 or 1, 2. I forget what the order is, and it'll do partitions of 2, but only offset 1 at a time.
Oh,
and so it gets you, yeah.
Oh, that's good to know. That's because I'm afraid that when we get to the end, like I might not get a value.
Yeah.
It may not.
Yeah. It'd be partition 2, 1 collection, and you'll get all the pairs that overlap.
Good to know. That would be a better solution here. Anyway, I did some tests, but I don't know if any of them were reliable because the vowel count just varied from, in the auto-generated test that I was doing. So don't really have any evidence on like which of these were faster or if I actually made it better along the way.
Can you show, like, I'm intrigued. I didn't even think to try to make it faster. Like I got the illusion, I'm like, I'm good. I'm going to go back to work, But can you show a little bit of how you generated the million line or the million character string? Because I'd like to try making mine faster. Like I have a couple of ideas, but I don't know the generation stuff.
Well, this isn't a good way to do it. It needs more work on the test because it does generate, and I generate a lot, but it's not scientific enough because the test isn't repeating. But I'll show you what I did here.
Yeah.
It's simple. So just requiring Clojure test check generators. And then here I'm in is how many cars I want to put into my sequence. And so then I generate a vector of alpha characters, gen-car alpha here, and give it like 1,000. I was doing 1,000, 10,000, 100,000, a million, and just seeing how that trended, and it trended like this.
Cool.
And then I was sure I wrapped it in a do wall because it goes real fast because this is all lazy. So I just get a lazy response real quick. I was like, man, this is an awesome constant time. It's looking good. 1,000, a million. Like, that's awesome. Like, but that doesn't add up. So I threw the do all on there, and then, yeah, I got a nice surprise. So I think that this generator here needs to be a little bit smarter in terms of like, maybe using the alpha gen percentages. You can get, I forgot what function it is, but you can say X% of the time, give me, this generator. And then the other percent get the other, another generator. And that way you could really control what that character set looked like. You could also use a generator and just get a fixed, this is probably not as good, but just get a fixed generated set and then run that through multiple code variations. But I like, knowing what we're running the test over. That was long. Any other questions on the generator here or anything?
I don't have any questions. That's
But
very thorough.
I just had a question. that is not related to this particular problem, but for generators, do you know offhand if there is a generator for either fixed length strings or bounded length strings, like all strings that are less than or equal to, let's say, 15 characters? Offhand, I can go look up. I'm just asking.
Yeah, I didn't see this in the test check, but spec gen has the call of, and in that one you can specify mins and maxes.
Oh, okay.
I just had test check at hand there, so I didn't want to get another namespace, so I just used what the.
Yeah, actually, today I was working on something with spec, and that's what caused me to ask this question, because I was trying to generate strings that were that would fit inside a database field that had a max length. Desmond, did you have a solution you wanted to talk about?
I don't have any code. I was wondering though if make this linear mapping through from the left and keeping track of the most recent vowel, so you have the distance to the most recent at each index from the left, and then do the same thing from the right, so you have the distance to the next vowel on the right at each index, and then loop through one more time where you take the minimum of those two.
So then you only go through the data 3 times, no matter what.
Yes, that way you'd be linear instead of quadratic. But I don't have the code to prove it.
Well, I don't know. Is anyone brave enough to live code something right now?
I'm not set up for it, but yeah, I'm fine.
So Desmond, could you say that one more time? You're talking about keeping track of the state as you're going over the sequence.
So yeah, the first map would produce a list that has index the distance to the closest vowel on the left. So that means as you're going, you can do it in a greedy way. You just need to know what was the most recent that you've seen. What was the index of the most recent vowel? Take the distance between your current and that index, and then do the same thing coming from the right. So now you have 2 lists, one with the closest vowel on the left and one with the closest vowel on the right, and then would go through and take the minimum of those 2 lists at each index.
Yeah, that's right. As I was looking at, I think you could do that. As I was looking at the transducers, I put some transducers into my solution, and I was like, well, what about stateful transducers, right? Is there a way to do it there? But it's not, I couldn't look ahead. So you don't even have to use a transducer, but you could definitely remember the last vowel, right? And as you're iterating through, track that distance. But I think if you did it in both ways and then mend them, you could do that with a map even.
Yeah.
The feature of having multiple collections into map is really...
I think that's one of those, like, I can't believe I did not know that in the past. It's like you can pass as many maps. I mean, I think it's as many maps as you want, right? You can pass like thousands of maps, but usually people only pass one. Not maps, collections.
Yeah.
Let's try it.
Anybody feeling good about live coding, or? If you all want to, I'll try it if you want to, but if we want to move on, do something else. It's cool, but that
Do you mind being the typer and we are the typist, and we'll all be the backseat drivers?
yeah.
I
well,
actually really like. I actually wish we did that more often because sometimes we throw up code on the screen and that can be valuable, but it's also nice to see the creative process, like how do people get started, how do they experiment, that kind of thing.
That's true. I agree with that. Then you get to see someone's REPL-driven development.
Yeah, and this project isn't really set up like the way I normally do REPL-driven development. So it'll be a little weird, but we'll have it. We'll be okay. I just learned this trick. I couldn't get my REPL going through make. And I figured out that it's because of buffering. So it was buffering the whole line. So I wouldn't see anything interactive until I hit enter. And then I would see the result, and then I would not see anything else.
Whoa.
I'm not that good with these kinds of shell things. So it took me a while to figure that out, but I did. So I figured out a way to turn buffering off. So now I got this. I'm really happy because I can just use make for everything now. Okay. So just to orient, this is Vim, I got a split, there's code over here and this split, and then we've got a REPL. Okay.
What's your convention for adding a star at the end?
I don't want to think of another name, so I'm just gonna
Throw some punctuation on the end. Okay.
what do we want to name this? What's this? We'll just call it experiment. Unless somebody's got something good right now.
Nope, sounds good. Could have called it Bob.
Bob.
No. So then, like what I would probably do is the first thing I would do is be like, make a function that just does, like we say we want to do something twice, we'll do the function that does it once and then we can call it twice, right? So like, the function would be like, return me a list of left nearest. Yeah, track. There you go.
Okay. And then this would be, we can make this. So would this would be where we're going to give it? We're going to give it a sequence and indexes, or just really a sequence and a pred.
Okay. Sorry, is that Desmond trying to say something? Anyway, I would say what would the predicate be?
Is it a vowel? Because then we could give it any pred, and we could just say like.
Oh, I see.
Because it's really, we're just tracking positions. I think it's abstract.
Right. Yeah, so the string and a predicate, right? Ooh.
I guess we're doing that. It would go this direction. Put the collection last.
Yeah, I think that's the convention.
Okay.
It's more like map than it is like assoc.
Yeah. All right. So how we want to
We basically want to statefully walk through the list, right?
Yeah, so we could use reduce for that.
Could use reduce
One
or
way.
loop,
Yeah.
or just recur, calling the function.
Sure.
What's everyone's preferred stateful? I think reduce is my go-to usually.
I guess I probably use reduce until the number of parameters gets
Like the amount of state.
yeah, and then I would recur.
All right, cool. So you guys are liking reduce. Here's where I'm like, yeah, I had to volunteer, huh? Okay,
Okay.
so
No, it's okay.
are we trying to stay inside the reduce, or is it outside?
Well, so with reduce, you want to have, so you need to, your accumulator needs to have your state and your result. So you do reduce and then a function. What I always do whenever I do reduce and then the input, like the collection. So XS. And then I go before XS and say like, what's my accumulator? Like what's the value that I'm going to be returning from every invocation of the reducing function? And so I need two things. I need the index and the resulting, like the index of the last vowel. And I need to keep a collection of the distances, right? So inside of that vector, we put two things. We put a vector and, 0, I guess. That makes sense?
Yeah, so not the type, not the first value here, but you're talking about the input to the function?
Right.
Okay. And you were saying what we need to have in here is the first arg is the accumulator, right?
Right. It's basically what we want to return. What are we trying to figure out? We want a vector of distances, right? So that's the first. Well, no, this is like the seed value. So it's like just a bracket.
I got
like
you.
Just
okay. Yeah. So right now that's an empty vector, but we can seed that with something else, like the. I'm tracking with you now, Nate.
right.
But are you saying that we should seed that with some like pre-known shape of the data that we're going to get out?
Right. Yeah. Go ahead.
Can't we seed it with the empty array and then we append at each step? So
That's what I had in mind, and I think that's why I felt kind of slow on the uptake, because you could define this shape here. I just I was assuming it was an empty vector, but we could define something here. But maybe if we leave that for now and go to the function here, like what shape we're looking for. I'll do a full.
Yeah, I usually do too, and
So the accumulators first. I usually.
I'm curious, when do you use the function syntax and when do you use the pound sign?
Every time I'm using reduce, I find that I'm gonna probably use some anon function in there somewhere. And when you can't have anonymous function inside another anonymous function. And so like, I'm always like, it bends my head up a bit. So I have like the function to reduce, I just always do it as fn.
Gotcha.
Yeah, also I think in this case, it's good to name the parameters. To give meaningful names to the parameters.
Right, not
percent 1%.
%1 and %2, yeah.
Yeah.
Okay, and then the values that we're sending in are characters, right?
Yeah, they're probably X
Right.
in this case, or char, whatever.
Yeah. Okay. Cool.
Oh, you're right. We do need a different shape for the seed.
Right. So I think for the seed, we should put, it's like open square bracket, close square bracket, space 0, close square bracket. Like basically, it's a
Right.
vector of a vector and the initial. That's what I've been thinking about. Is like
So the
what,
0 is after the.
no, put the put the 0. It's like open, close, close.
Space.
Sorry, open, close, space 0, close.
Yeah, so we're returning a tuple of an empty list, and we're starting with a tuple of an empty list and 0.
Yeah.
So
And then
I
want to
think,
destructure your function as well.
yeah, so that's the cool thing is inside your function, you can actually destructure the accumulator into, like, just put a bracket around accumulator and make it accumulator, and then, you know, last distance or whatever.
Okay, and this first one is that's our state. That's our list.
Yeah,
That would be the accumulator,
the
right?
list of the nearest on the left, or
Yeah, you modified the right arg. You want to modify the left arg.
yeah, this should be our accumulator.
Got it. Yep.
Right, so that's the accumulator right there. So ACC goes there.
Yeah.
And I was actually thinking about it because we're going to do mins on this, right? So I think that the seed value should be like max int or something like that, or max. Because what if the first character is an F and then an A? Well, you don't want it to be.
Right, it guarantees that there's one vowel, but it could be over on the right. So
Way on the right.
Comparison, we we want the default to be something really low.
Because we're going to take them in.
Oh,
So if we're going to be wrong, we want.
really high. Yeah,
right.
I mean, could we use a nil there? Like we haven't seen it. It's nil. Because, well, I guess the question is.
Yeah.
You all know. Is this last scene? That's the index of the last vowel or the last match that we've seen.
The last thing that was successful in predicate. Yeah.
Okay. Would a nil make sense there? Like we haven't seen one.
I think that would work because then then when you're trying to do the min at the end, you're like either 1 or nil, and then you have to filter out the nils first because min would blow up on the nil. But yeah, that would work.
Or you could process that inside of your reduce function by saying if the last scene is nil, then do max, which is basically just the same thing as starting with the max.
Okay.
Seems like they would all work.
Yeah, so let's start off with nil. Let's do the nil like you said, Tyson, as the 0 right there. Okay, so then inside of our function, we want to do an if, right?
Yeah, nice. So in this case, we append 0.
Right. We want to conj on a 0.
Yeah. Oh, yeah, right. We want to conj it.
So but you're right to put it in a vector because you want to return a vector because the state is a vector. So you want a vector of a conj and 0, right? No, a conj and my current index.
Current index.
No, you want 0, right? Because you want the distance to the vowel. So if you are a vowel, then you should be conjing 0.
Right. Yeah, you conj 0, but then it's a tuple, right?
We want to conj onto the accumulator 0 here.
Right. And then what's that?
Oh, I see what you mean. What,
that's got to be the
second thing
index.
you return. Yeah, the second thing you return is the index. Yeah.
Yeah, but here we need the index.
Uh-oh.
So yeah, we need another.
Right, we needed all that keep indexed, right?
Yeah.
Map index, keep indexed. Reduce indexed, is there one of those? We got one of those?
No, there is no reduced indexed.
No, but
That would be,
you could put one of the starting things, like you've got the nil.
Yeah, we just have to add
another parameter in there, which is the index. Accumulator, last seen, and
index. Yeah.
index.
an index.
And then that one would start at 0.
Or do we want, can we?
You can't put it outside there. Yeah.
Yeah, it's got to go inside. Yep.
Well, we could wrap x's in tuples of index values, but I like this other one. This way it's better.
That's true.
So accumulator, last seen, and I.
Yeah.
Yeah.
We're all friends. We can use single letter variable names.
And so here we're going to return, we're going to conj accumulator with a 0.
So this should be I, and then the next one should be I plus 1.
Yeah.
Correct. Yes.
All right. And
I and ink one. Yep.
Yeah.
Ink eye. Ink in my eye. Yes.
Cool. And then here we will do, what is it?
Last seen.
I minus last seen.
Yeah. Yeah.
I think you need to put in a, if last seen is nil, that the condition we talked about.
Well, we could handle that in the minning. I think
You gotta check here, right? Because otherwise, if minus I and last seen is nil, then you'll have a problem.
Well, yeah,
that's
right
true.
here, if last seen is nil, you're going to get a null pointer exception.
Yeah.
Darn that math.
No, probably. So how would you all like to fix that? Because it's so, yeah, it's going to blow up.
I would just do like an if, an inline if. Or
No, maybe where the last scene is, just that one. Put an if around there.
well, we want to, if the last scene is nil, then we
Right.
want to subtract. If otherwise, we want to put in the max value, right?
Right. Sorry. Yes.
It seems like it might be a little bit less code if we just go with the min instead of nil.
So when you say min instead of nil, you're talking about like the int min, the min int, or min.
Yeah, of course that is sort of hard codes that were coming from the left, but we've already kind of done that.
Oh, I see. So you use min like the minimum, so that if you subtract, it'll be really high and it won't be.
Then we're gonna have to thread through another parameter, right? Just for that, because when we come from the other direction, will it still be min?
No,
I think we should just do is when we just reverse a string, like you can just do a couple of reverses maybe, like
Yeah.
and not.
Okay.
Although I mean it's a big string, so reversing, you know, could take
Oh, that's true. Yeah, if you reverse, then you're still coming from
from the left.
left. Yeah, that's true.
We might also get weird values if they're both, if they're, you know, if they're both that min value, that's going to be the output.
Yeah, I think we should do is inside where you have the -I last seen, just wrap that in when last seen, and we'll get nils.
Yeah.
And then we can, like, let's just verify that it works, and then we can iterate from there because we still haven't run the code yet.
Yep. But does that complete the code, we think?
Last seen.
Should be.
I think we need to add one more to the state map or the state list there. You got a vector nil, and you should put 0 for the index.
Yeah. Right.
All right.
Okay.
Oh man, did we lose a? Did we lose Oh no, cool. Julio's still there. Hadn't heard you in a while.
This is the manual way. So, okay. So I just copied it over and pasted it into the REPL. So we can track nearest. Oh shoot, we need to get our pred here.
Just throw a set. Yeah, you're set there. Yeah, you got a set.
Oh, that's right. Can we just do this? We can just do this, can't we?
Mm-hmm.
Or,
Well, yeah, no pound at the beginning. Like it's just a set is a function too.
yeah. Yeah. Okay. Right. We just want to call it. And then.
Oh.
We were all convinced it was just gonna like spit this out a beautiful answer.
You know, if you type code into an editor enough times, there is a chance that it'll run right the first time. So there is a chance. It doesn't really happen that often for me. So good to know that we're together are the same.
And an excellent print here in BE.
Numbers.
I didn't know about that asterisk E. Nice.
Usually I would have PST for print stack trace, but somehow that's not working for me here. I used a new template generator for this project, so it's like really different for me. Ooh.
Oh, it's because you put it in the edit in the.
Yeah. Try to get it wired up, but that's even scarier than live coding is live.
Hey, how about just take the whole function, paste it in the chat, and I'll share and be the typer now. Hey, let's do the hand because I have my connected editor. I can.
Cool.
I don't mind. You've done wonderfully, and now it's my turn to experience the wrath of.
Okay, start running. Here comes the baton.
Okay, I guess I should share.
I feel like I can go get a beer now.
Okay. Here. Oh, I didn't share yet. All right. So we have track nearest. All right. Let's see. Line 35. The ink eye.
Oh yeah, we can't. Oh no, it's 0, right? It should be 0.
Should be 0, yeah. Hmm. Whoa, look at that. Okay. Make it a little bigger so it's easier to see. At the bottom over here. So first iteration. And then, whoa, look at that.
Hmm.
Did we not close a parens? Oh no, we didn't. We didn't close the parens after last scene.
Oh, you know what? I think Parenfer got weird on me there. If I went in and edit, because I probably put in the win, and sometimes it doesn't. You got to actually do a line break to get it to go
Tried
back.
to like fix it for you. Yeah. Yeah. So we need another parens after that, right? Because that's the conj that we're trying to close. And then we have last scene, and then we have ink
Yeah,
eye.
so that one needs to come in here. Oops.
Yeah. Right.
Nate, you use Parenfer, right? Parenfer.
I use the structural editing, so Vim SexB.
Okay.
I don't know if it uses parent for under the hood or whatever, but
Well, it
so
just
like
worked. Drop that in there and it worked. Sometimes when I do that, it's like, nope, we're going to put it out at the end. And I actually have to do a line break to, and
to like get it to like come back in.
yeah, I think that's what happened here. Good eye.
So that looks right.
Hey, that looks right. Okay. Yeah, so then the end thing is just first, right?
All right.
There you go. Wow, look at that.
Cool.
That's okay, so then what do we want to do now?
I think we can reverse it now, right? To make the other one, can we just revert, run reverse on babb?
And isn't the reverse efficient? Like it's not actually going to reverse the string, right?
Right.
I hope
That's
so.
what we want, right?
Yeah.
No, 0, 1. Right.
Yeah, that's right. Yeah.
So then I guess we go track nearest, reverse. So now that's, oh.
Wait, hold on. That's
No, the
yeah. We want reverse. Yeah, we want to reverse that reverse. Yeah, exactly. Yeah.
Okay, so now we got to do what def and nearest vowels experimental. All right, what do we do?
Now I think we map, well, we're going to have problems that we're going to sort out, but you can map min and then 2 of those inputs. And that's at least going to get the shape of the input, right? It's going to blow up on the nils. We're fixing it.
We got to sort that out. Yeah.
So map on forward and backward.
Yep.
Yep.
Yeah, and then we just need a nil safe min.
Ah, didn't get all of it there. And nil say it here. Let's just run this one. Hey, it worked. Oh, we need something with non-vowels. Yeah, so map min, huh? We're always guaranteed that there's at least one vowel, right?
Yeah, so there shouldn't be any where it's nil on both sides.
Right.
Well, B.
Right, but I think the problem description says there'll always be at least one vowel.
Oh, okay, cool. That's the rules.
That's what I would do. Oh,
Can you do a fnil?
yeah, I think so. How do you do fnil? Fnil, I've always had a hard time. Fnil
And then the function, so in this case, min, and then the value you want to use instead of a nil.
0, 0.
Or is it max?
Oh, nice. Yeah. I'm
I
over
feel
here looking up the docs on FNL.
Oh, you're right. It would be like int max, right?
Yeah. And you don't need the sharp sign in front.
What's the max? What's the number for max?
I think it's max _ integer. I think. All caps. Maybe.
I'm getting nothing here. Oh, integer. That's what it is. Max value.
Value. Ah. Yeah.
So like that. Hey, there you go.
All right. That's a good entry into this like performant. Which of these is more performant? This is really like three passes.
Yeah, here. I will.
Well, we've got a few reverses, but I think this would be better, right? Because it's not the set we're iterating over is, we're not doing that exponentially.
All right, there you go, Tyson. I hand the code back to you, because you're the one with the generators.
Okay.
I could walk myself through setting that up, but I think we don't have 4 more hours.
Okay. So screen sharing. Sharing, good.
Is anyone familiar with RSEC? RSEC?
RSeq?
Yeah, I was just looking up the time for reverse. Apparently RSeq is constant time and reverse is linear.
Cool.
RSeq is lazy.
So let's do a test with this, and then we'll swap it out for RSeq and see how that goes.
Yeah.
Let's see. First, let's just generate. We'll generate something known. I'm gonna just like
like the alphabet 1,000 times.
Let's see. So if we def. This should be. No. Oh. This. Okay. We'll get there. One sec. Okay. So there we go, 1,000. See this. Make sure I get this in. Sorry, y'all. This is time. I'm just using time, which is just going to do it one time. You all probably know there's a library called Criterium that you can use to benchmark, and it'll run it a bunch of times. And we can do that here in a sec. Okay, so now we just do all nearest vowels. And we just get the input, right?
Oh, I think, did you get my track nearest? You need to fix the track nearest problem that we had, that we fixed when I got the code.
The friend, yeah.
Oh, did I not? I thought I.
You only evaluated the nearest vowels at X, but not the
wrong one. No. Is this
That's two
it?
functions.
Right here?
I think you need, so the when block at the end of it needs to have, there's a parenthesis, yeah. Oh, okay, I see what you mean by hitting enter.
Yeah.
Wow, that's interesting. I never used part. Is it part infer?
Yeah, and it just happens sometimes, like when you need to go back in and you're editing inside something. Usually I see it happening, but yeah. But this is right. Nearest vowels.
Yeah.
Oh, geez.
Oh.
Which Java version are we using?
Oh, look at that. I got that right. It's 14.
Oh, wow.
Any ideas here? It's probably, maybe I just have, I'm in a crazy state because I've been copying and pasting things around.
Oh, interesting.
It's sort of weird.
Oh, interesting. Wow.
Let me copy from chat. We'll just make sure. Otherwise, I'll hand it back to you. But I think that the I'm not really doing anything fancy right now to do the test. I was just doing time and calling. I did do some checks with Criterion. It's got a function bench and Criterion core / bench that you can run, and it will like call it 60 times, 100 times, or whatever. It kind of
Interesting.
tell you like stuff like that, which is a better way to go. But I can't find chat right now. Where's the?
So do you just need the gen? Where do you get the Clojure test check generators? What's the depth for that? Or is it just there all the time?
I think you have to include it. But let me check. Right there, or Clojure test check.
Can you copy and paste that in the chat, and I'll restart my Ripple.
And then I'll get Criterion while you're adding dependencies. Use depth Eden, right?
What's that?
Use depth Eden.
Yep. Oh, here, I'll share again. That's it. Yeah, so up above is my depth CDN. I guess Eden is a better way of saying it. So Jen, oh, there we go. I gotta look at your code again. Gen/generate. Hey, look at that. That's cool.
Yeah. Huh.
So 11 milliseconds for 1,000 characters.
That the
Not
fact
too bad.
I got was about 30 seconds for a million.
For a million.
I don't know if that was, but here again, when you're doing numbers that big, the generator is going to decide more like the performance of that, because it might like have a lot of vowels. And for this solution, that wouldn't be so bad, I don't think.
So for 10,000, it was 140 milliseconds. For 100,000, it's still half a second. For a million, right? A million. Oh, a million is 2.3 seconds.
Wow.
Hey, there we go.
All right, Desmond.
Yeah, very nice.
Nice.
We can do it.
That was fun.
That was very fun. Very cool, because that's a dramatic difference. Can we run it again? Or could you try, did you do bench? Let's do bench to see. Well, we can't call the generator in, we want to separate the, it's fine. Just run that again a couple times just to see how it trends, but we don't want to include the generator, the generation inside the bench.
Right.
Oh, I see what you mean. Like do let string. My Vim is dying because it's, oh, I guess I should put that, because it's having to do all this printing millions of characters. Okay, there we go. So a million is 200 milliseconds.
Yeah, that's a big bump. That's a good bump. A few times I literally just had to kill the REPL, like it didn't return in a while. And I was like, okay.
That's pretty cool.
What happens if we swap reverse for rseek?
Yeah. We should start to see consistent times here.
rseek like that? Just both of them?
Yeah. rseq. Yeah.
Difference being just that it's lazy.
762. We got one up here that was 947.
Was that the difference, that it's lazy, or was it because it's using a different operation to take off the tail?
What I saw on Clojure docs just said, you're looking at reverse, try rseek. It's the same thing, but constant time. And then I looked it up and someone said,
oh, wow, look at this. I think it has to do with how many vowels it actually picks. Because look, this one is rseek. So 762,
right.
Look at this,
input.
19.
Yeah.
Like, I'm guessing there was like an A followed by 1,000 Bs.
That's interesting that we get that on this solution, though. I was definitely getting that impact when we're looping, you know, when we're not looping, but when we're mapping over the vowel set, the vowel index, right? That index differs. So then we got a big string and a lot of vowels for each item we're looping over.
Yeah, in this case, we're going through the whole thing exactly 3 times, no matter what.
If rseek is constant, maybe what other thing in here is not constant time? And if we get those replaced with constant time things, this should be a constant time. We could get this to a constant time operation, I think.
Well, it's still going to be linear. We have to go over the whole.
Yeah. What I mean is for the whole, for
each step.
Yeah.
Yeah.
So in fact, not constant time at all.
No, but I think you meant constant time independent of the number of vowels.
That's right. That's what I meant. Yeah. But it
right.
would actually be linear over the.
Right. Constant, like stable. Yeah.
Yeah. Very cool.
Well, I think we win.
Yep.
I think we should do this again. This was fun.
Yeah, it was.
Now that the heart palpitations and the nervous energy is gone, that we actually made it. You know.
Well, and you know, for the nervousness of live coding in front of an audience, right? You know, maybe passing it around like that is a good antidote, you know. And then you always have the options like, oh, I'm stuck, you know, pass it to the next person. Could be
Is
nice.
there like a better solution for actually sharing the editor in some way? And just passing the control around?
I remember the apropos the podcast. They would do like a video segment where like the first half was like Clojure news and the second half was them fiddling around in a REPL. And one of them made a like shared JavaScript, like everyone is editing the same code REPL kind of thing. So I don't know if that might be useful.
I do like seeing the tooling though.
Yeah.
Yeah,
it's not usually how I have things set up because I use the different template, but I like handing it off to you, Nate, and then seeing like how you're doing this in your editor. Part of the fun for me.
Yeah, that is. Yeah.
Yeah, I think just basically having a way of copying and pasting around code would be, I think, the best thing. And the chat's not that bad. Oh, I see you put the criterion stuff in there.
Thanks, Desmond. That was a creative way to look at that. It's very cool.
Yeah, that was really cool.
Yeah, thanks for indulging me and going along with it. That was cool. Yeah, actually, I really like the opportunity to, you know, see a solution come together. I think, yeah, the more we can do that, for me, that's the best way to learn. You know, talking with other people in the process and seeing other people's techniques and things. Even just like little stuff, like you know, building your reduce from the end. You know, start with the input and then your seed, and just like little stuff like that is nice to see how other people think.
Yeah, I think it'd be fun to do this again. Just do the.
Yeah. Also, the process of starting with the building blocks, which I imagine is something you probably would see different in a non-Clojure meetup. Like, I feel like that might be a little bit of Clojure flavor, that, you know, you start with your like composable building blocks. The move to, like, Tyson immediately was like, oh, well, you know, this is something that's just nearest whatever, right? Like, when you abstract something is probably, you know, differs from person to person, and it's cool to see that thought process.
Absolutely.
Yeah, that's cool. I forgot we did that, but it is just the nearest pred. I guess we got some baked in number. It's like in some number stuff baked in there, but, or I guess, no, there's not, is it? We're talking index. So yeah, we can, whatever, is it capital, right? We can,
yeah, nearest
pred on it.
Punctuation.
That's cool.
Yeah.
We built a thing, y'all.
Yeah.
More importantly, we wrote a reduce function, or a reducer, you know, in the round here, you know.
I think we're halfway to that Clojure framework we were talking about before.
Well, cool then.
Yeah.
All right.
All right. So let's, if there are any ideas for the next meetup, we can also talk on Slack or email or whatever. But this may be a good idea to try and do more of these.
Yeah, that was fun. I'd be down for doing another solve next time.
Yeah, in fact, didn't you, I think it was you, Tyson, I can't remember, but who originally suggested that we solve this problem live coding. Or I don't remember if it was you or Nate, but one of you suggested it. And I said, no, let's try and come up with the answers and display them. But it turned out we did both. So
yeah, no, I like that. I like that better. If we'd have done it as a group, we'd have gotten through one one solution, which would probably, well, I don't know. We have had a lot of decision making with four people.
True.
Yeah, and the model of like, you know, everybody thinks about the problem ahead of time, maybe, you know, shows up with something, and then we like combine the potpourri of approaches.
Yeah, I do like that, but I also like the part of the process is the stumbling around. Like, you know, I'd like to think that, you know, like if you look at a person who's a bricklayer after being a bricklayer for a decade, like they're really fast right off the bat. But if you look at a programmer who's been programming for a decade, there's still that like initial, like, I don't even know what the shape of anything is. I don't even know how to program. Is this even going to work? You know? But I mean, you hone in on something and you come to something that I think that's better, but like that is a common thing to all programmers, no matter how many years you've been doing it. So, and that's where the fun and the learning is. Like, I think, I don't know about you guys, but I learned a bunch just like, I really need to remember to use keep indexed.
Yeah. And I think also, you know, watching, you know, experienced programmers fumbling around is also an important part of, you know, lowering the barrier of entry to other people, especially, you know, if someone comes to a Clojure meetup and they're not experienced Clojure programmers. If we have, you know, people that are new to Clojure and we throw up, you know, fancy looking algorithms and they don't see the fumbling around, it might be sort of intimidating.
Yeah, I agree. Like if you look at the reduce, that function track nearest, it's got a reduce in it, you know. And if you just said, oh, this is a reduce function and this is this, and you know, these are the accumulators and whatever, but it's like just watching it come to life. I think anyone should be able to understand that, you know, at least track it along the way.
I'll be honest. I'm driving this code session and you all say reduce and I'm like, all right, let's strap in.
And also, yeah, when you're not just live coding, but live pair programming like that, you have to name everything. You know, you have to say, you know, the first argument is the accumulator. You know, you have to give it a name, as opposed to, you know, if you're live coding and talking about what you're gonna make for dinner.
That's true. Well, we can always see what Eric Normand puts into his newsletter just before the meetup.
Okay.
Next time.
Cool.
Wow.
Thanks.
Yeah, thanks.
Thanks, everyone.
Okay, thanks y'all.
Have a good week. Yeah. Hey, are you gonna post this on YouTube or something?
Yeah, just give me a little bit of time to edit out my fumble, you know, of the yeah. I will.
Awesome. Cool.
Usually
It'll be fun to link to it.
for it to roll in, but once it does, I'll put it in the Slack.
Cool.
Thanks.
All right. Well, thank you, everyone.
Bye.
Have a good May.
Bye.
Bye.
All right. See you guys.
Bye, Julio.